Okay, this is Mrs. A with another how to solve a polynomial problem. So we're all getting our summer packets and we're looking through them and starting to solve them in preparation for our next school year, which is only in 2 or 3 months. So this problem comes from a summer math packet for a student that was in Algebra 1 and is going into Algebra 2. So this is reviewing Algebra 1 skills. So let's jump in. Use the given function below to answer the following questions. F of x is equal to negative 3 times x plus 2 squared minus 4. And the questions that have to be answered are, what is the y-intercept of f of x? What are the x-intercepts of f of x? What are the coordinates of the vertex of the function? What is the axis of symmetry? Write the function in standard form. Does the parabola open up or down? And what is the domain and range of f of x? So now I typically take these problems and go running into the Polya problem solving process template. But what I want to do today is start to show you that you don't need the template. The template is just two perpendicular lines. And you need to use that way, that way of solving polynomials is really what matters in that Polya problem solving approach. So what I want to do is I want to keep in mind on the side that the Polya problem solving process is always with me as I'm solving even summer problems. So I'm drawing my perpendicular lines and I'm making sure that I'm always remembering that I want to understand the polynomial, which means I'm going to notice things about it. I'm going to look at its structure. And I'm going to use that structure in my experiences. If I have a list of methods or heuristics, I'm going to use that to help me plan, which is to justify a polynomial approach. And then I have the solve it stage, which is to take that plan and then solve it using the steps from that plan. And then the last thing is to always look back. And let's jump in. So let's see. I want you to look at this polynomial and think about, what do you understand? What do you notice about this problem? What do you understand about the structure of the polynomial? Just take a look at it without even, you can put a couple of notes together, but don't jump in and solve it quite yet. And then when you're done, come back. Put the video on pause and then come back. Okay, so what I understand when I look at this polynomial, the first thing I'm noticing with all of these questions are that I'm wondering, if I just graph the polynomial, won't most of the questions just, I could just glean the answers from the graph. So right away I'm thinking my plan is probably going to be to graph it and then try to solve it off of the graph. Now the next thing I want to be thinking about is the structure of this polynomial. It can't be made any simpler. There's no more GCFs or anything that can be taken out. And I don't want to distribute out the terms because this is in vertex form. Do you remember vertex form from what you learned over the year? Like with vertex form, we have, I'm just going to write this out. We had f of, let's do that. Okay. We have f of x is equal to some constant times x minus h plus k, and that x minus h, that's squared. Now that's a standard parent function, and if I look at the original function, I can see here's my constant, I see here's my x minus h, and I'm not worried about the fact that that's a plus 2, it just means that h is actually negative 2, and my plus k is actually a negative 4. I'm also seeing there's my little exponent that shows me that this is in vertex form. I'm not even going to write that here. This is a vertex form equation, so I don't want to put it in standard form. I'm just going to leave it in vertex form because vertex form is actually wonderful for making graphs of polynomials because it's got the vertex right in there. Okay, now what else do I notice? I am just looking. I definitely noticed that the parabola is going to be facing down because I got that -3. And whenever that a is a negative, it means it's going to face down. I also notice it's going to be kind of a squished parabola because of that -3. Usually, like if a is 1, we're going to have that nice rounded looking parabola. But as that a grows, the function f of x starts to increase at a faster rate than x does. So therefore, the y starts increasing faster than the x. So our parabola is going to look very squishy, I'm thinking. Okay, I'm ready to start graphing this. So I think I understand the polynomial of the hand. I've got a plan that most of my problems are going to come straight from a graph, and I'm going to solve it off of that graph. So let's jump in and start to graph the polynomial. All right, so one thing I love about Notability is that I can graph using their graphing paper, and makes things so much easier. I'm going to use the one with the most squares. There we go. I don't even know if I'm going to need that many, but that's okay. Just keep it all square. Okay, so let's see. I just want to draw in. It would be so nice if it came already with the x and the y axes already drawn in, but that's okay. I think what they need to do in Notability is just open up the stickies so that more people can be adding stickers to their sticker box that they have in there. All right, but we can just take a second to draw that out. Okay, so let's think. What does this parabola look like? So usually what we're doing when we're trying to draw out the graph is we're thinking about some key points. And one of the first points that we care about when it's a parabola is the vertex. And so we can put the vertex in easily because this is in vertex form. So we have -2 and -4. I'm going to count each line as a as a 1. I'm sorry, I'm going to count each line as a 2. So it'll be 2, 4, 6, 8. So let's see, if I have -2, I'm going to go down the first line, and I have -4, I'm going to go down 2. So my vertex is going to be here, and the numbers are going to be, the coordinate is going to be -2, -4. All right, so that's my vertex. And I know that this is going to face down because, as we said before, the a value, the constant value, is a negative. So we've got a -3. So this thing's facing downward. I'm wondering if I can easily, it might be better if I wrote this out, but I'm thinking I can easily find the y-intercept. So remember, when we're finding the y-intercept, the x has to be set to 0. So looking back at this equation, I am putting in a 0 for that x, and I'm thinking 0 plus 2 is 2. 2 squared is 4. 4 times -3 is -12. -12 minus 4 is -16. Okay, so it's 0, -16 is my point. So 2, 4, 6, 8, 10, 12, 14, 16. Here we go. So this is going to be 0, -16. Now, usually when I'm drawing a parabola, I want a few points, and I could, go back to the function to get some more, but I can also use the fact that a parabola has symmetry, and we know that that line of symmetry is going to be on the -2. X is equal to -2. So we just say x is equal to -2 is our line of symmetry, and we can use that to come up with another point. And this point is going to be the same distance to that line of symmetry as our y-intercept. So this is going to be -4, -16. Okay, and so we've got what our parabola looks like. It's just as we expected. It's really kind of a squishy parabola. And there we go. Hopefully that's neat, and it shows that it's going to keep expanding outward. That's not going straight on that line. And that's our parabola. So let's jump in and And let's jump in and start to try to solve. So let's see. What is the y-intercept of f? So the y-intercept we said was 0, -16. Oh, so this is working good. All right, so what are the, I'm gonna move this over, move this, squish this up a little. What are the x-intercepts of f? Oh, again, I mean, the answer is right there. That parabola does not touch the x-axis, so there are no real x-intercepts. So my answer is there, hopefully I'll have enough time to finish this, are no x, or I should say, actually there's no real x-intercepts because there are going to be two imaginary ones, but we just care about the real ones right now. Okay, what are the coordinates of the vertex of f of the function? So we said that it's -2, -4, and this is really working. Our solving is going really quickly having this graph here. What is the axis of symmetry? Again, we said x is equal to -2. And what, all right, so this one we can't answer. Write the function in standard form. That we're not going to get from our graph. Let's try answering the other questions and see if there's anything else that doesn't open up to us from the graph. Does parabola f open up or down? It opens down. What is the domain of f? By looking at this graph, I can see going across the x-axis from left to right that, you know, as this parabola is going out to the left, it's going to keep slowly, but it's going to keep increasing for infinity. And the same thing on the right. So I have a domain of -infinity to +infinity. And I'm using my interval notation. What is the range of f? So let's use a different color here. Let's use yellow. So for the domain, I'm sorry, for the range, I'm going up, I'm going bottom, and I'm going upward, right? So if I can go far down, it just forever. Again, it's infinity on the bottom side, and then going all the way up, I'm limited here by the vertex. That's going to be my maximum number. So the range, the maximum range is going to be -4. And I think that's it. We did it. The only other question we want to do is we want to look at writing f in standard form, and that we really just have to do the legwork for. You know, there's really no shortcuts or anything. We really just have to expand out the formula. And see here how like I'm remembering it. I have this in mind mentally. And remember, Polya always says, make sure you have the problem in your head so that you can quickly refer to it and you're not always having to run back to the problem. So I'm just going to expand out the x plus 2, x plus 2. I'm going to remember that there's the -4 here. And that's going to give me x squared. And that's going to give me 2x, that's going to give me 2x, so that's plus 4x, and that's going to give me plus 4. And that's minus 4. Now I have to expand out the -3, so we have -3x squared plus, 3x squared minus 12x minus 12 minus 4. And that gives me the final answer of -3x squared minus 12x minus 16. That is f of x, the function, in standard form. And there's no way of simplifying this any further. There's no common factors or greatest common factors. This here is my standard form. I did it. That was everything. The only thing that's left, you know, if we look at what we did, we want to be looking back at our work. I'm just trying to see if there's somewhere I can keep my nice little graph. I'll put them over here. And so what we did was we understood the problem. We looked at the function and we realized that the function is in vertex form and that the best thing we could do is come up with a graph. And I think that was a great approach because we were able to quickly get through all the answers. We then planned to do that, to take the graph and come up with the answers. We took the graph and we solved the answers, and now we're looking back at our work and making sure it holds water. Now looking at the -3 and it's facing down. I'm looking at the vertex, -2, -4. You know, I think everything really does hold water. The only thing I guess I am wondering a little bit about is the -3x squared minus 12x minus 16. You know, I could quickly jump into Math Papa, and I'm trying to think if I did that here, that we could see, I'm going to get rid of the 0 and calculate out, and we see that, yeah, -3x squared minus 12x minus 16. It's perfect. And if we do set it to 0, we do see that the answer is, if we find the discriminant, we see the answer to the discriminant is -48. And whenever it's a negative discriminant, we know that there are no real roots. So again, our parabola is really holding water, and the approach that we used to solve it is really making sense. I'm just trying to think if maybe, you know, we look at it in Desmos too, and just make sure our understanding of the parabola was correct. And again, yeah, it's a very skinny, squished parabola. It's got a vertex of -2, -4, and it is intersecting with the y at -16, 0, -16, and it never intercepts with the x. I feel wonderful about my answer. Yeah, you can always use those tools that are out there to make sure that your answer holds water, that your approach is comparable with others. You can also reach out to a friend or bring it to your teacher. Look at the answer key. You know, sometimes the answer key just tells you the answer and doesn't show you the approach. But reach out to a friend, see what they did. Maybe they came up with a more efficient, simpler approach that avoided hard work. And that's why we always want to make sure we spend time on that look back stage, seeing if there was a better way. And that's it. I hope you had a wonderful time starting to solve your summer math packets. And please feel free to forward me with any questions or comments you have on this problem. Or if you have a question in your summer packet that you can't get to the answer for, let me know.